Imagine trudging across a vast sheet of ice, with the horizon stretching endlessly in every direction. It's cold, desolate, and seemingly void of anything significant, until you spot it, a dark, unassuming rock sitting atop the pristine snow. At first glance, it might not seem like much, but this small fragment could very well be a piece of space itself. A meteorite, millions of miles away from its origin, crash-landing on Earth. It's hard to believe, but in the seemingly inhospitable frozen expanse of Antarctica, some of the most fascinating cosmic secrets are waiting to be discovered. While most places on Earth offer little in the way of significant scientific revelations, Antarctica stands out as a natural magnet, pulling in these ancient cosmic visitors like moths to a flame. Scientists have long puzzled over why this frozen, barren continent is home to so many meteorites, rocks that could hold answers to questions about the origins of the solar system, and perhaps even life itself. Meteorites fall all over the world, but Antarctica offers a truly unique advantage. Its near-uniform, icy landscape is the perfect backdrop for meteorite hunting. The stark white surface contrasts sharply with the dark rocks, making them stand out in a way that would be impossible in areas covered with dirt, sand, or vegetation. The harsh, dry conditions of the continent also help preserve the meteorites better than anywhere else on Earth. In warmer, wetter regions, these space rocks would corrode and erode over time, losing vital clues to their origins. But Antarctica's frozen air and low humidity act as a natural preservation system, keeping these fragments of space pristine for thousands, even millions of years. As if nature had designed the continent specifically for meteorite discovery, Antarctica's glaciers and ice sheets play a crucial role in concentrating meteorites into areas known as meteorite stranding zones. Over time, the massive rivers of ice slowly move and churn, carrying meteorites from the edges of the ice to specific spots where they can be more easily located. These natural conveyor belts of ice have turned Antarctica into a treasure trove for scientists, who recover tens of thousands of meteorites every year. From tiny pebbles to massive rocks weighing several pounds, these meteorites come in all shapes and sizes. Some are pieces of asteroids, remnants of the ancient building blocks of our solar system. Some are rare lunar meteorites, rocks ejected from the moon by powerful impacts. And some even come from Mars, blasted into space when asteroids collided with the red planet millions of years ago. One of the most remarkable discoveries was made in 1984, in the Allen Hills region of Antarctica. A meteorite, named ALH 84001, turned heads when scientists found microscopic structures inside that some believed might be evidence of ancient Martian life. While the debate about this discovery continues to this day, it opened up an entirely new area of research into the geology and history of Mars. Studying meteorites from other worlds provides a unique glimpse into the past and allows scientists to explore worlds beyond our own. But finding these space rocks isn't as simple as it sounds. Antarctica's extreme conditions, temperatures that can plunge to -60 degrees Fahrenheit, fierce winds, and blinding sunlight reflected off the ice, make the search for meteorites a grueling challenge. Scientists spend weeks scouring vast stretches of ice, often using snowmobiles to cover as much ground as possible. When they find a meteorite, it's carefully documented, bagged, and kept in pristine conditions to avoid contamination. After all, these space relics contain secrets that scientists hope will help unlock the mysteries of our solar system, and the origins of life itself. In recent years, technological advancements have revolutionized meteorite hunting. Satellite imagery and machine learning are now used to pinpoint areas where meteorites are most likely to be found. By analyzing factors like ice flow, terrain, and climate conditions, scientists can narrow down search areas and increase their chances of success. This modern approach to an ancient treasure hunt has already yielded impressive results, increasing the efficiency and scope of meteorite collection in Antarctica. So, why all this effort? What makes these space rocks so important? The answer lies in the secrets they hold. Meteorites are like time capsules, preserving information about the early solar system, details about the formation of planets, the chemistry of the universe, and even the building blocks of life. By studying meteorites, scientists can uncover clues about where we came from and how our world fits into the broader cosmic picture. Antarctica, with its extreme environment and natural preservation system, might seem like an unlikely place for groundbreaking scientific discoveries, but its role as a cosmic treasure chest is undeniable. Every year, new meteorites are found, and with them, new revelations about the universe. As scientists continue to explore the icy continent, one can't help but wonder, what other secrets might Antarctica be hiding beneath its frozen surface? While Antarctica is famous for its icy expanse and harsh conditions, beneath its frozen surface lies another striking contrast: fire. Yes, despite being one of the coldest places on Earth, Antarctica is home to some of the most active volcanoes in the world. More than 130 volcanoes are scattered beneath the thick ice, waiting to be studied by scientists and adding another layer of mystery to this enigmatic land. Among these volcanoes, Mount Erebus stands out as the southernmost active volcano on the planet. Situated on Ross Island, it has been erupting continuously since the early 1970s, spewing gas, steam, and occasionally molten rock into the freezing Antarctic air. One of its most fascinating features is its persistent lava lake, a rare and extraordinary sight in the world's coldest climate. But Mount Erebus is not alone in Antarctica. Deception Island, a horseshoe-shaped caldera in the South Shetland Islands, is another active volcano that intrigues scientists. Its last eruption occurred in the late 1960s, and though the island has been relatively quiet since then, its geothermal activity continues to captivate researchers. What makes Deception Island especially interesting is its role in human history. It has been a hub for whalers, researchers, and adventurers, all drawn to its natural harbors and the geothermal warmth that makes it a surprisingly inviting destination in the icy Antarctic environment. And then there are the hidden giants, volcanoes buried beneath Antarctica's thick ice sheets. These elusive volcanoes are far more difficult to study, but they're far from irrelevant. When volcanic activity occurs beneath the ice, it can trigger the melting of large quantities of ice, creating subglacial lakes and rivers. These meltwaters can act as lubricants, accelerating the movement of ice sheets toward the ocean and contributing to rising sea levels. While one eruption may not have an immediate global impact, the collective effect of several eruptions could have far-reaching consequences for the planet's climate. Understanding these volcanic processes is crucial for predicting future changes in our environment. But how do scientists study these icy, fiery realms of Antarctica? It's not an easy task. With temperatures often plummeting to near impossible lows, the continent's remoteness presents one of the most formidable research challenges on Earth. Even with cutting-edge technology like seismometers and remote sensing tools, predicting volcanic eruptions is more art than science. But every discovery brings us one step closer to understanding how fire and ice coexist and influence each other in one of the most extreme places on the planet. Yet, despite these formidable challenges, Antarctica's icy wilderness is teeming with life. Though it may seem like a barren wasteland, this frozen land is home to some of the most resilient creatures on Earth. From microscopic life forms thriving in subglacial lakes to the famous emperor penguins enduring frigid temperatures of up to -60°F, life has found a way to survive and thrive in this unforgiving environment. Antarctic fish, for example, have developed antifreeze proteins in their blood to prevent their bodies from freezing in the icy waters. Similarly, seals are able to stay submerged for over an hour by slowing their heart rate, and conserving oxygen. The wonders of life in Antarctica don't end there. Despite the freezing temperatures and total darkness, subglacial lakes harbor thriving microbial communities, isolated from the outside world for millions of years. These tiny organisms have adapted to live under extreme pressure, cold, and darkness, offering scientists a fascinating glimpse into how life might exist on other icy planets, such as Europa or Enceladus. But even in this hostile environment, life is under threat. Climate change is reshaping Antarctica's landscape, accelerating ice melt and altering ecosystems. As ice melts, it exposes meteorites that were once hidden, but it also changes habitats for creatures like penguins and seals. The delicate balance of life on the continent is in jeopardy, and scientists are racing against time to understand the long-term effects of these changes. Yet, despite these challenges, Antarctica remains a place of incredible resilience. Whether it's the scientific communities living in cutting-edge research stations or the wildlife battling the harshest conditions on Earth, Antarctica is a testament to human perseverance and the unyielding spirit of life itself. The secrets hidden beneath its icy surface continue to inspire and drive us to understand not only our planet but also the universe beyond. So why does this remote, frozen land matter so much? Antarctica's global impact cannot be overstated. Its ice sheets hold nearly 70% of the world's freshwater. If they were to melt entirely, sea levels could rise by over 200 feet, flooding coastal cities around the globe. Even small changes in the ice sheet's dynamics could trigger catastrophic consequences. As climate change accelerates, Antarctica's role in regulating global temperatures and ocean currents has never been more crucial. Studying the continent's ice, its ecosystems, and its extraterrestrial visitors will help shape the future of our planet, and perhaps, even